5.4, working with integrals, and let's do our last one. We're going to talk about the mean value theorem for integrals. You're like, what? Didn't we already do the mean value theorem in Calc 1? Yep. Yeah, here it comes. But we already have it. It's the same thing we just did in the last video. So we have a mean value theorem for integrals. Well, all it's saying is, well, look, you got some sort of function. Well, shit, let me use something bigger. Got some function from A to B. Some point A, some point B. And there's some average height, right? So it's right here. There's some average frickin' height. That's the average value of the function on that interval. And it happens at some point C, F of C. So now what our game is going to be is we want to actually go and find that C. So it says, here's a theorem. Let F be continuous on the interval from A to B, just like the picture. Closed interval, not open. Then there must be a point in the open interval, in between A and B, bigger than A, smaller than B, such that the average value is equal to whatever that height might be. And then we can go and find the values of X, or C. And that's going to be our game. So full disclosure, I'm about to use a problem straight from your textbook. You can go and look this up yourself. Well, we want to find the points. We want to look and find the points, or the point, who knows. On the open interval from 0 to 1, at which, let's say f of x is equal to, I'm pretending like I'm coming up with this myself. I'm reading and writing. It's average value. Writing. It's tough. It's tough. On the closed interval. So a lot of writing. Could have had that already prepped and ready to go, but that's not how I do things. All right, so we want to find the points that are going to be on that open interval. That's just from back here, that open interval, which f of x is equal to 2x times 1 minus x is equal to its average value on 0, 1. Let's go. So the first game is we want to find the average value. Here it is. So we want to find the average value. Or we can call it some f of c. Because we're going to have to find that c, or that x value. Well, we know that this is equal to 1 over b minus a, the integral from a to b of our function dx. So let's replace. Our a is 0, our b is 1. So let's go through. Okay, well, what do we got? So it's 1 over our b minus a. Well, that's nice. From 0 to 1 of our function, and our function is 2x times 1 minus x dx. So we want to go and solve for this. Go figure out what's up. Let's go find that average value. So let's clean this up. Well, 1 over 1, I'm pretty sure is just 1. All right, so we can just skip that part. Now, let's get things antiderivative ready. That's not antiderivative ready. We don't have product rules. But we sure got power rules. So we bring it through. So it looks like we have 2x minus 2x squared dx. Let's go. Let's go get this thing. That's going to be equal to our average value. So let's take our antiderivative. The antiderivative of 2x is just x squared. The antiderivative of negative 2x squared is negative 2/3 x cubed. Notice I am not explaining my steps, because we should know how to do this. So now we're ready to go. So we got something squared minus 2/3 something cubed. And so you will never do something like this. Minus 0. Sorry, we're plugging in 0. Are you okay with me skipping that step? I just plugged in 0 at the end. And now we just pop in our upper bound. The 1. The zeros at the end, they don't make any difference. Sorry about that. So this is equal to 1 minus 2/3, which is equal to 1/3. Very cool. We found the average value of our function. Very cool. How nice is that? So our f of c, or our average value of the function, is 1/3. But that's not what we're looking for. We're actually looking to find what is the value of x that makes that true in the interval from 0 to 1. Now, here's kind of the issue. Our function, get all that nonsense out of there. Our function was that 2x times 1 minus x, or 2x minus 2x cubed. But when you graph this thing out, it's a parabola facing down. Parabola facing down. Well, conveniently, this is 1, and right there, that's at 0, but the 1/3, that means we have 2 different points. There's 2 values of c in between 0 and 1. So how the heck are we ever going to go find those values of c or x? We set the average value equal to the gosh darn function, and then we solve. So 1/3 is equal to 2x minus 2x cubed. It's cubed. Why did I write cubed? Come on, man. Did you see that? Were you noticing? You're going like, teacher, you suck. God. There we go. Now we can get rid of that cube. All right. Well, this looks like a quadratic. If you're just able to factor this and solve, please teach me. Please teach me. I don't know how to do this. I'm going to move everything over to one side and put it in descending order. Now we do the quadratic formula. I am not going through the steps as to how you do the gosh darn quadratic formula. You can do that on your own, or you could use completing the square or whatever it is that you want, and we would find out that x is equal to 1 minus the square root of 1 over 3 divided by 2, and that's approximately 0.211. And you would find that x is equal to 1 plus the square root of 1 over 3 divided by 2, which is approximately equal to 0.789. Now, in class, these are your answers. There's your 2 values. These are exact. They're perfect. But you might do some homework where it asks you to round. So this would be the rounded answers, and those would be your 2 values. The values of x, but we call them c. Right? There it is. There's your 0.211. And this one right here, you get your 0.789. And there it is. There's your average value. Sorry for my crappy writing. Don't feel like I explained this all that well, but it's not the biggest topic in the world, but we do need to be proficient with it. And any math majors, oh my goodness, that's going to become your freaking life later. But for those of us engineers, people who want to do bio, stuff like that, hey, we got to play the game. We got to learn how to do this, and then we're going to move on. But the next one, these are my favorite sections. Golly, I love integration techniques. We're going to go into substitution rule. Hopefully you've seen it before, but oh my goodness, I'm going to make this stuff. Let's go. Let's go. Some fun stuff in the next one. So I'll see you then.